All right, we're going to draw the vector V indicated and graph the equivalent position vector. We're going to do number 15 here. So the vector V, start with an axis since we have two, the initial point and the terminal point defined with ordered pairs. We're going to need an X and Y axis. So I'm going to get some straight lines for that. So let's draw a Y and an X. And on our first point, X is 5. 1, 2, 3, 4, 5. And Y is -3. 1, 2, 3. So that's our initial point right here. And our terminal point is -1. So going back to the origin, I go -1 and up 2. 1, 2. And there I draw a vector going from the initial point to the terminal point. So that initial point was 5, -3, and that terminal point, that tip of that arrow, is at -1, 2. Now the equivalent position vector means that I take this vector and move it so it starts at the origin. So that initial point is now at the origin. I'm actually going to change the color too so we can see that that is the position vector. So the distance, the length of the vector and the direction are the same, but it starts at the origin. I'm sorry. And this thing I want to label with my position vector name, which is the horizontal component, which is the length of that line, which is -6, and the vertical component, so that's the length of that line, 1, 2, 3, 4, 5. I did this by duplicating it. Because I have it electronically, so I duplicated it exactly. But you can also, algebraically, you can look at that vertical component here and that horizontal component here. Algebraic, so that's graphically, you can just count. Or algebraically, you can look at the x, what's the change in x. So my x ends at -1 and it started at 5. So my result will be at -6. And my vertical component, let's see, I'll do horizontal component equals that. And then the vertical component starts at, or it ends at 2 and starts at -3. So minus a -3 gives me 2 plus 3, which is 5. So that gives me that position vector of -6, 5.